Alright, we have two last examples to consider in reciprocal functions. The first, example 15, says consider f of x is equal to x squared plus x minus 6. What is its reciprocal function? Well, the reciprocal function is simply the function you get by doing 1 divided by x squared plus x minus 6. Alright, B says state the non-permissible values of x and the equations of the vertical asymptotes of the reciprocal function. Well, to state the non-permissible values, we need to factor the denominator as much as possible. Factors is x plus 3 and x minus 2, which gives us two non-permissible values, x equals negative 3, or x equals 2. We're going to have two asymptotes, two vertical asymptotes, x equals negative 3 and x equals 2. Alright, what are the x-intercepts and y-intercepts of the reciprocal function? Let's see. The x-intercepts means y is equal to 0. So we get 0 is equal to 1 over x squared plus x minus 6. And multiplying by both sides, we get 0 equals 1, which doesn't make any sense. So there must be no x-intercepts. Y-intercepts, on the other hand, is what we get when we make x equals 0. So we get y is equal to 1 over 0 squared plus 0 minus 6. So we get y equals negative 1/6. It says sketch the graphs now of f of x and its reciprocal function y equals 1 over f of x. Alright, let's take a look at this. When we graph y equals x squared plus x minus 6, we know that it's a parabola that opens up. It crosses when x is equal to negative 3 and x is equal to 2. Halfway between there. It's going to look something like that. So here we have a parabola, and the graph is y equals x squared plus x minus 6. If you have trouble finding that graph, use your graphing calculator. Use Wolfram Alpha. I just did it in my head roughly. Now, we get, let me just clean that up there a little bit. There we go, that looks better. We get two asymptotes for the reciprocal function. Alright, our x-intercepts turn into vertical asymptotes. Now, a quadratic reciprocal function looks a little bit different than a linear one. We still have the same principles. Alright? They still cross when the y values are 1. And it still gets close to to the asymptote. Right, it gets close to the asymptote, but it doesn't cross it. Similarly here. So we've got these two branches going out. What about this spot in between the vertical asymptotes? Right? They're still going to cross here and here. It says that the y-intercept is negative 1/6, so that's like up there somewhere. And it does, it gets we get this spot down there. Alright, so we've got these three branches. Got this one, and this third one. Alright, almost all parabolas are going to look something like that. Alright, you know often when you're given a technique, they want you to do it backwards also. And here we have the graph of a reciprocal function, which is y equals 1 over ax plus b, where a and b are non-zero constants as shown. So sketch the graph of the original function, y equals f of x, and determine the original function. Well, let's do a first, because in this case a is going to be easiest. First thing you know, the original function has x-intercepts at the asymptotes. So right here, right there, my original function has an x-intercept on that asymptote. Also, they've given me one of the points on the reciprocal graph. If I want to find the associated point on the original graph, all I have to do is take the reciprocal of the y value. See, my x value stays the same. I take the reciprocal of negative 1 over 4 and I get negative 4. So it passes through this point. So we have a straight line passing through 2 points. Here's my original function. Alright, I don't know the equation of it yet. Alright, there's my original. Alright, now, if you're graphing and you're pretty accurate, you can tell right now that it looks like we've got the y-intercept of the original function is 4, and it would appear that the slope is also 4. So we would think that the equation should be probably y equals 4x plus 4. Alright? The y-intercept is 4. Right, that gives us that one. And the slope gives us the 4x. Now, the other way to do this is to write the equation of a line. This is a line passing through negative 2 and negative 4 and negative 1 and 0. Right, we can calculate the slope, change in y over change in x. So we got negative 4 subtract 0 over negative 2 subtract negative 1. So this is negative 4 over negative 1. We do have a slope of 4. And you might remember that the slope point form of a line, which is pretty important in calculus, so if you have forgot it, it's not going to hurt you to brush up on it, is y minus y1 equals m times x minus x1. So we've got y minus negative 4 is equal to 4 times x minus negative 2. So y plus 4 is equal to 4 times x plus 2. So get y plus 4 is equal to 4x plus 8. I've ran out of room, so I'm just going to slide over here to get y is equal to 4x plus 4, which is what we suspected the answer would be. Alright, so we've done two things this lesson. I've introduced you to the reciprocal function. Right? To graph a reciprocal function, you graph the original function. The x-intercepts of the original function turn into vertical asymptotes. Right? And the two graphs cross when the y value is positive 1 or negative 1. Right? Then you sketch your graph based on your asymptotes. Right, the second thing, we determined the original equation given the reciprocal. And the key ideas there are you need to know one of the points on the original graph. Well, you need to know two of the points on the original graph to graph a line. Right? So if you know the asymptote, that's where one of the x-intercepts was. And they'll probably have to give you some other information, like specifically what one of these points is. Alright, to solidify these ideas in your head, practice on the assignment, pages 403 to 409. Do number 1 to 8 odd parts, 9, 11, 13, and 20. Alright, have a good day.